So we can see that the dimension of v, that is L into t to the power minus 1, matches with the second term on the right hand side, that is 80, but not with the first term on the right hand side. So since the dimension of all the terms on the two sides of an equation must be same, we can say that this particular physical relation is not correct. Now let's talk about the limitations of dimensional analysis. The dimensional analysis gives no information about pure numeric and non-dimensional constants. It gives no information about the dependence of a physical quantity on trigonometric, exponential and logarithmic function. If a physical quantity depends upon more than 3 physical quantities, then dimensional analysis cannot be used to derive their relationship. And this method gives no information about dimensional constants such as universal constant for gravitation, that is g, and Planck constant, etc. Now we will start the chapter Introduction to Kinematics. So first let's talk about reference frame. So what is a reference frame? A reference frame is a coordinate system with respect to which position, displacement, velocity, acceleration, etc. of a particle is defined. There is no absolute frame of reference in the universe, as everything is moving with some velocity. Usually the frame of reference which is associated with the Earth, we consider it as an absolute frame of reference unless otherwise mentioned. So even though the Earth is moving, we consider it as an absolute frame of reference. Now let's look at some definition first. First we'll define position. Position is a vector quantity which is represented by vector r, and position of a particle is a vector with the tail at the origin of the frame of reference and head at the point where the particle is. So let's see this with the help of an animation. So as you can see in this animation, x and y axis is our frame of reference. This is the origin of our frame of reference. This is our particle. So the position vector of this particle would be a vector which has its tail at the origin and its head at the particle itself, and we represent this vector by r. So this is all about position vector. Now let's define displacement and distance. Displacement is also a vector quantity which is defined as the change in the position vector. So suppose a particle is at position vector r1 initially, and after some time it moves to position vector r2. Then the displacement of the particle will be given as vector r2 minus vector r1, irrespective of the path the particle takes while moving from r1 to r2. And the distance is defined as